So let's look at this a little bit more closely. So let's say here are some of the myofilaments. Here's some of the actin. These are the myofilaments again. Here's some actin. And then here's some myosin. And myosin is actually a little bit thicker than the actin, so let's draw this a little bit thicker. Here's some myosin. Here's some myosin. So it goes actin, myosin, actin, myosin. You get the idea. Okay, so this whole thing, this bundle of actin and myosin all together is the myofibril. This whole tube that goes all the way down of a bundle of actin and myosin together is the myofibril. Now, the actin and myosin making up this tube, the tube is actually a barrel of the actin and myosin bundled together, one barrel after the other barrel, just next to each other, butted up next to each other. Here's another one. Just these barrels lined up end to end to make this long tube called the myofibril. Now these barrels that are lined up end to end, here's a barrel, here's a barrel, here's a barrel. These are each one sarcomere. And as you can see where the sarcomere ends and the next sarcomere begins, that's the Z disc, because it looks like a bunch of Z's stacked up on top of each other, and that just shows where one sarcomere ends and the other sarcomere begins. So here's a Z disc right here. And then over all of this is this pretty blue thing. I'll draw it down here. This pretty blue thing. And it does this whole little mess of pretty patterns in the middle here. And then toward the end of each sarcomere, it kind of bubbles out. So this is a covering that goes around these sarcomeres. This blue thing, this pretty blue thing. And this blue thing is called the Sarcoplasmic Reticulum. Sarcoplasmic Reticulum. And then around that, around the Sarcoplasmic Reticulum, there is the wrapper. There's a membrane that wraps around this. And it covers this whole thing. And this is a membrane. And it does this all along down the tube, down the myofibril. It comes up here, it wraps around. So this membrane wraps around this whole thing over the sarcoplasmic reticulum. And this membrane is called the sarcolemma. And it's got that silent N in there, sarcolemma. So the sarcolemma is the membrane that wraps around the entire myofibril. Now here's a better picture of the sarcolemma wrapped around the myofibril. Here's the exterior visualization of it. So this whole pink thing is the sarcolemma. And you can see here this pretty blue, the sarcoplasmic reticulum is underneath that, is a layer underneath the sarcolemma. And then underneath that, underneath the sarcoplasmic reticulum, are the actin and myosin, the myofilaments. And the whole thing is the myofibril. And I know I keep repeating myself, but I want to make sure that you have this anatomy down so you can understand what I'm saying. Now that we have that established, So why is this sarcolemma so important, wrapping around the myofibril here? The sarcolemma, that's the level where the nerves come down. Here's the end of a nerve, where the nerves come down, and they kind of hook on to the sarcolemma right here. So this is a neuron. And again, this is where I'll tell you again, you really need to watch the videos part 1 and 2 of the action potential and watch the previous parts to this video series on muscle contraction in order to know what I'm talking about. So I'd really rather have you watch that video on action potential, the 2 videos on action potential first, so you understand what's going on up here with the neuron, because it's going to make a lot more sense. So here's the neuron, and this long part of the neuron is called the axon, and it's kind of like an electrical cord. Because what it does is it conducts the electricity. Let's get some yellow for electricity. It conducts the electricity all the way down here, down the neuron, down the tail of the axon, and it gets down here to where the axon bulbs out, right here, and we call this the end bulb of the neuron, of course. And that's where it connects with the sarcolemma being this pink covering, this membrane that wraps around each sarcomere. Now here's a close-up of what I was just going over. Here is the axon of the nerve, and here is the end bulb of the nerve, or the neuron, actually. Neuron is the more correct term for it. You'll find out when you get to the nervous system that a nerve actually means something else. So neuron, here's the axon up here. This is the end bulb, obviously what looks like a bulb. And the electricity comes down here, comes down the axon, and it comes all the way down. It follows the axon down until it gets down to the end bulb, and it goes down. This is a cylinder, so it actually goes down all around the axon, gets down to the end bulb, and where it ends, where the electricity, the pathways for the electricity end, are called end terminals. And when the electricity gets down here to the end terminals, there are these gates. They're just doorways. In anatomy and physiology, they call them gates or channels, gated channels, just meaning that's a channel with a gate on it. It's pretty much just a door. Just think door. So here's a door, and here's a door, and also outside of this, floating around, is calcium. Floating around, here's calcium, calcium. Now when the electricity gets down to this end terminal, it hits these gated channels, these doors. And these are called voltage gated channels. Let's go back to the blue. Voltage gated channels. And all that means is that they're doors that open up when a voltage hits it, a volt. And volts are what we measure electricity with. So pretty much when the electricity hits these doors, the doors open. That's what voltage gated means. The channels mean doors or doorways, and they're closed until the voltage from the electricity comes down and then hits the doors, zzz, shocks them, and the doors open. So when the doors open, they look kind of like this now. And what happens when these open? Well, these channels are specifically for calcium. These are voltage gated calcium channels. So when these doors open, the calcium rushes in. The calcium comes into this doorway. And the calcium comes into this doorway. Now we have calcium on the inside of the end bulb of the neuron. So now we have calcium on the inside of this end bulb of the neuron. Now what else is in this inside this end bulb of a neuron are these little bubbles. Okay, I'm going to draw them with green. There are these little bubbles that hang out in the end bulb. And these bubbles are called vesicles. And vesicle is just another name for like a cavity or a bubble or something that's got something in it. Now what's in these vesicles? Inside these vesicles are ACH, and that is short for acetylcholine. So ACH are in these little vesicles. Now what happens when the calcium comes in? Remember the calcium came in these doors that opened, the voltage gated calcium channels, because the electricity buzzed them and it made them open, and so the calcium could get in. So the calcium's inside now, and what the calcium does is the calcium goes over to these vesicles, goes over to these vesicles, goes over to these vesicles, and when they go over to the vesicles, they burst open these vesicles and open them up. So what happens? So the acetylcholine gets out of the vesicles. When the acetylcholine gets out of the vesicles, not only do they come out of the vesicles and into the end bulb, but they leave the end bulb and they go out and float outside in between the end bulb and the sarcolemma of the sarcomere. So now we have ACH floating around out here. So the calcium comes in through the open gates that are opened because the electricity coming down here gets to it, shocks it, zzz, opens it. Calcium comes in. The calcium buzzes these little vesicles. It bursts open the vesicles. The ACH escapes, and the ACH comes out here into this little gap between the sarcolemma and the end bulb. Now this little gap between the end bulb and the sarcolemma, that is called a cleft. A cleft just means a gap. What kind of cleft is it? What kind of gap? It's called the synaptic cleft. And the synaptic cleft, it's called a synaptic cleft because the junction where this end bulb meets the sarcolemma is called a synapse. And that's just the point of connection, where they connect. Where they connect is called a synapse. So the gap in between the two structures, between the end bulb and the sarcolemma, the sarcomere, is called the synaptic cleft. Got that? Okay, pretty easy, right? Now, what's going on with this ACH that's floating around out here? Well, the ACH comes over to the sarcolemma, and the ACH activates some more gated channels, or doorways. So let's put some more doorways down here. There's some doors here on the membrane, the sarcolemma membrane. There are all these doors here. Now these doors are not voltage gated channels. They're channels. The channels are the door part. The voltage gated means they're opened by electricity hitting them. But these are not voltage gated channels. These are chemical gated channels. Now another word for chemical gated is ligand. So you're going to hear them used interchangeably. They're either chemical gated channels or they're called ligand channels or ligand receptors. It all means the same thing. Just like the doors up here that are voltage gated, when the electricity hit them, they opened. Well, the doors down here, they're chemical gated. So when the chemical of ACH hits them, they open. So what happens when these guys open? What happens when these doors open? Well, when these doors open, there's another ion hanging out around here, waiting to get in, and that's sodium. Sodium's hanging out all over the place. So when the ACH, the acetylcholine, comes across, bursts out of the vesicles in the end bulb, crosses that synaptic cleft, and they touch these chemical gated channels, it opens the doors, and then the sodium can go inside the doors and get into the sarcolemma, into the membrane. So now, as you can see, we have a cleaner picture here. The acetylcholine that are in the vesicles, they get released, they come down out into the synaptic cleft, they go down, the chemicals trigger these doors to open, and when the doors open, then the sodium can get in. So now there's sodium inside, all this sodium that was outside, just floating around out there. Now all the sodium comes in and floods inside this membrane, inside the sarcolemma. Okay, so now we have all this sodium inside. Now this sodium, it just brings a whole bunch of positive charge, because sodium is a positive ion, right? So it brings all this positive charge inside the membrane. So this makes the charge of the membrane of that sarcolemma go up. And that's the charge of the membrane, of the sarcolemma membrane. So the charge goes up since it has all these positive ions. It makes it more electropositive. So now it has all this electrical energy. This is my pathetic attempt at drawing a lightning bolt. So it has this electric energy that's positive inside the membrane, inside the sarcolemma. Now this positive charge from the sodium that's now inside, the sodium travels along the membrane, making it more positively charged. But now see, in the sarcolemma, we skipped something in anatomy. In this sarcomere, in this sarcolemma that wraps around it, the sarcolemma actually dips inside. So that's a bad drawing. But if you look at the top of it, it's like it goes inside to touch the sarcomere inside of it. Remember that pretty blue color that we had that was wrapping around the sarcomere, that's Sarcoplasmic Reticulum? Well, this sarcolemma has little divots, has little creases that dip down inside to touch the sarcolemma, or the Sarcoplasmic Reticulum, that pretty blue that's inside. So here is the Sarcoplasmic Reticulum. Now, when the positive charge from the sodium, it goes along the outskirts of the sarcolemma of the membrane, and then it gets to where the sarcolemma has a little wrinkle inside that dips inside. The positive charge follows the membrane down into those like little divots that go in to touch the sarcolemma. Now let's color this area. It's just space, this area where the sarcolemma dips in and forms little wrinkles that dip in and touch the sarcoplasmic reticulum underneath it. Okay, these little divots that go inside this little shape where the sarcolemma goes inside, these are called T-tubules. Because really when you look at the picture of the anatomy, they look like little tubes. I'm not doing a good job drawing it, but they look like little tubes when they go in and touch the sarcolemma down here. So they're called T-tubules. And the positive charge from the sodium follows along the membrane and goes down into the T-tubules. Now let's take a closer look up at the T-tubules and what's really going on with that positive charge, that sodium's positive charge. So here's a close-up of these T-tubules where the sarcolemma dips down and makes like a wrinkle that goes inside to touch the sarcoplasmic reticulum, this pretty blue color here. Now also, you know, we've been dealing with channels or doors, those voltage gated channels that the electricity opens, and then the chemical gated channels that the acetylcholine opens and lets the sodium in. Well, there's also little doors down here. And actually, I'll put them over here so you can see how they function. There's little doors down here. These are voltage gated channels. Now, what is voltage gated channels again? Voltage gated channels. Voltage gated means they're opened by a charge. So what's a charge? These little positive sodiums. That makes it charged. So these come down and they make these open. And here, I'll do it over here on this side. This makes more sense. So these open, these little doors open, because the charge from the sodium is the voltage. And that makes it zzz, it's electricity pretty much. And the electricity buzzes this and the doors open. So what happens? Well, there's our old friend calcium that's hanging out. Or I'm sorry, there's our old friend calcium that's hanging out. And the calcium just kind of hangs out in the ends of the sarcoplasmic reticulum, this pretty blue. So when these doors open, it lets the calcium out, and then the calcium goes inside the myofibril, inside this entire sarcomere. So the calcium goes through these doors, through these voltage gated channels that are opened by the sodium, and the calcium goes inside, or calcium goes inside the sarcomere. Now what's the sarcomere? The sarcomere, remember, are the little barrels that are stacked end to end that make up a myofibril. And inside those sarcomeres, inside the myofibrils, are those myofilaments, the actin and myosin. So pretty much the calcium is going to go visit the actin and myosin. Now that we understand how the calcium gets inside, this is how the calcium gets inside the myofibrils to go down and react with the myofilaments. And this is why you need to have watched the other videos on muscle contraction, the first video on muscle contraction, because this goes over it in a little bit better manner. But now we understand how the calcium gets inside. So here comes the calcium, and the calcium goes and knocks the troponin off. And if you don't remember what troponin is, go and review the first video in this series. It knocks the troponin off. The troponin moves the tropomyosin off, and it exposes these actin active sites on the actin. So the myosin, these little golf clubs, the myosin can come down and interact with the actin, with the active sites. See how the myosin can get down there now? Because see, before, these golf clubs, they couldn't get to the actin because they were blocked by this troponin and tropomyosin. But the calcium takes care of that. The calcium knocks the troponin and tropomyosin away. So the golf clubs, the myosin, can get down and interact with the actin. And when it interacts with the actin, let's get another one down here. Here's a good actin. Here's an actin, and here's an actin active site, the little holes in the actin. So the myosin, the golf club, comes down and it sticks the golf club head into those holes, into the actin active sites. And when it does that, it pivots, like here's the golf club. It pivots right on this little angle right here. So it moves the golf club head back. And when it moves the golf club head back, it pulls, since it's stuck in the actin active site, it pulls the actin back. Well, the actin is strung on this string. It's like a string of pearls, really. And so it pulls this entire string back with it. And this string, this action of pulling this entire myofilament, this actin, back this way, that's what shortens the muscle. So when here's your arm, here's an arm, and then here's your hand. So when it pulls the actin back, it pulls this hand up because it shortens the muscle, and then you are able to, bend your hand or bend your arm back like this and make a muscle. See, it pulls it shorter. So you can you can flex your muscle, you can bend your arm back. So if this is confusing, go back and watch the first muscle, the first one in this series, because this explains this whole concept a lot more in detail. But I wanted to give you a better view of what happens leading up to this point with the calcium coming in and how the calcium gets in there and everything. So remember, the electrical stimulus from the neuron comes down and it ends up hooking up with the muscle. Here's the muscle at the sarcolemma. The positive charge lets the calcium come in, and then that's where we are now. Calcium comes in and it kicks the troponin and tropomyosin out of the way. The myosin, the little golf clubs, can then go down and insert themselves in the actin active sites, pulling it. It pulls this entire string, which results in you being able to flex your arm and bend your arm up and make a muscle. If you have any questions whatsoever, please feel free to contact me or leave a comment, and go ahead and, if you haven't before, look up my 2 videos, part 1 and part 2, on action potential, because that explains what's going on with the nerve. And if you understand what's going on with the nerve to begin with, these little gated channels and the positive ions, it makes a lot more sense. Thanks a lot.